Hello and welcome back. In today's video, I'm going to do the PCB design for the TP4056 circuit that we designed on the last video. And I will address some of the kind of questions that I've had on the previous video from some viewers. So hope you enjoyed this video, and if you have any further questions or clarifications that you need, please let me know in the comment section below. In the video today, I'll be covering the questions and going through the PCB design for this and showing you a bill of materials. What I'm going to do now is find suitable components for all the parts that I have on the schematic over here right now, assign them using the footprint assignment tool, and then go on to the PCB design. So now you can see I've updated the circuit schematic for the TP4056 battery charging circuit, and I've also basically gone through the footprint assignment for that section of the part as well. So I'm just going to quickly show you the bill of materials for the charging circuit. So obviously we are using the TP4056, DW01 and FS8205A as the main three components. Then we have obviously some other resistors and capacitors that go around this as well, which are basically mostly in here. So you've got the 100 nanofarad capacitor from our previous circuit, and we had some 22 microfarad capacitors on the previous circuit as well. So I didn't add a 10 microfarad capacitor as was recommended on the datasheet, because I just wanted to carry the 22 microfarad capacitor as I already have a line item for that. So let's now quickly do the PCB design for the TP4056 and go from there. So the first thing I'm going to do is open my PCB design. And obviously this was from our previous work that we did. I don't need this anymore, as I was just finally finishing off the PCB from last time. I will bring in the new components from the schematic, so update PCB with changes made to the schematic, and press the update button. So you can see now that I've got all the different parts in here. These are my two connections for the battery. One thing I'm going to do is move this a little bit down. So this is my edge layer. So I'm going to start moving all the components to roughly the right locations that I need them to be in. So I know that from the schematic, obviously, we have our TP4056 feeding the DW01, and then that is connected to FS8205. So I'll kind of lay it out in that arrangement first, and then we'll go from there. Our DW01 will go on top somewhere, and our FS8205 will go on the bottom somewhere here. R10 0.4 ohm resistor is connected to V-bus and goes to the charging circuit. So I will constantly be referencing the schematic to kind of get a layout of all the components that I need to put in the right place. And then we'll just go from there. Let me put all the components in approximately the right place, and then I'll start connecting them up. So now let's quickly talk about some of the tracks that I've got. So I've got most of the things connected already. You can see I've got one ground connection not made, and I've got this pin 4 not connected as well. I'm just going to have a quick look at what pin 4 is. So pin 4 is the VCC pin. Obviously that's quite important, as there will be a lot of current going in that direction. Pin 8 is just chip enable. That shouldn't have a lot of current going through that path, so I can afford to be a little bit less stringent on my tracking. So what I'm going to try and do is make sure that this connection over here is a very good thick track. Obviously I want these battery connection tracks to be very thick as well. When I say very thick, I need them to be thick enough for 1 amp of current. So I'll do some calculations on what I need in order to achieve that. On KiCad, you get this nice calculator tool, and you can use basically the track width calculator on this to calculate the temperature rise of a track with a given width and a thickness. So obviously the thickness of it, is determined by the manufacturers. We can specify copper thicknesses to them. So with a 0.3 mil track that's 20 millimeters in length, I should get a temperature rise of 10 degrees C with 1 amp of current. So obviously I would be happy with 10 degrees C because I'm not using these at any extreme temperatures. So I'm going to aim for tracks that are at least 0.3 millimeters thick. To add in different track classes, you can basically go to here, press the edit predefined sizes and add in different track thicknesses. So 0.25, just worked out we need a 0.3, so I'm going to go for 0.35 for the 1 amp tracks. And then 0.5 for where I can basically just have thick tracks because there's no constraints. For example, this one here. If you have a thick track, you need to make sure that you do it on the grounding side as well as the positive side, as that's where the current return will be. In this case, obviously, this capacitor is only for stabilization, so there's not going to be vast amounts of current going through this, but there will be a lot of current spikes that the capacitor will be supporting. So having multiple inductors is really good for parasitic. Whereas this copper track here, I want to make sure that I have that as thick as possible. So I'll try and aim for 0.5 here because I know I can see the room is there. So the track going to RA is basically this one over here. So this is sensing the battery voltage for DWE01 port. So there shouldn't be significant amount of current going through this path, so we can afford to have smaller tracks in there. So this track here, I can make that a little bit thinner. However, this track here, I need to make that as thick as possible. And I'm going to aim for 0.5, go to there and get the thickest track I can find. And change that to a 0.5 mil track over here. Obviously, this V-bus track is going to be carrying a lot of current, but this at the moment is temporary anyway, because I need to add in some switches and everything to control if this circuit is being powered by the battery or by the USB. So the connection I'm struggling with at the moment is just this one here, so BAT plus. I know 1 amp of current can flow through to the battery from this port here, so I need to make sure that the track is sufficiently thick to achieve that. To get a nice thick track onto battery plus, I think what I might need to do is move the 2 resistors for the LEDs onto the other side, and that will mean I can basically have a better track going between the battery input of this connection and this connection here. So let me do that now, and I'll do that by just deleting these sections here and moving this connection as low as possible. I can also move this one up, and that gives me nice easy access to the battery pin. I think a nice easy way to connect this is just adding a copper port, and it'll also help with the heat capacity of this port, as there will be a lot of current flowing through it. I'll also move this a little bit closer to save it a little bit of space. Obviously, these two LED tracks don't need to be that wide. They carried over from the other side, so I'll just change them back to 0.35. So now I should be able to make the battery connection. But what I will do is just use a ground port. You can see there's a bit of a choke here, but that track is so wide, I'm not really too concerned. But what I can do is cover over this and add in basically this, so that it's not so squared off anymore. And I can do the same thing on this side. So pressing the insert button, you add in node. I mean, that's a bit messy, but whatever, should be all right. You can see we've got a nice thick track going to here. We've got a sufficiently large track here. I mean, I can change that to a ground port as well, which I think I will do later on. And now finally, I just need to connect up this pin here. So finally, I will just connect up this section here somewhere. I think what I want to do is utilize the other side of the board for this. So what I'm going to do is put down a copper layer on this for the battery negative terminal. I think it'll result in a better design overall. So, and I get a nice neat track as well. Change the grid size a little bit and then go. I might be overdoing this a little bit. Do the same thing on here. Got the negative battery terminal. And there you have it. I think that's the PCB design done. The last thing I need to do is make sure that all my silkscreen bits are in the right place. So just gonna have a quick look on the 3D viewer to see what it looks like. As you can see, it's a big mess in terms of where my silkscreens are. So I'll resize them first. And to do that, you basically want to go to edit text and graphic properties, and then set reference designators and line width. I basically want to copy from here, so let me just see what I've put down here. So I've got 0.762 and 0.127. Line thickness, I'm not sure what this is referencing, but let's try that. So obviously that's worked, so that's fine. And then I'll just change this front to make sure that it's all in the right place. Got D1, got R6, got R5 here, got J2, which I want to add in a battery negative sign on there, because that will be more useful than J1 and J2. So let me put that here for now. And so if you want to add in silk screen text, you basically go into your front silk screen for this case, and then text. I'll just put down back plus. Go over here. And then I need another one, that's back minus. You can see this board is now starting to come together. I mean, that looks a bit messy, but whatever. Obviously, I can move this in a little bit, and then what I want to do for future is add in a minus 12 volt regulator, a plus 12 volt regulator, a 3v3 regulator. Keep watching for more. This is basically the charging circuit done for using the TP4056. I've never done this circuit before, so hopefully it's all okay. But if there's any mistakes, obviously I'll show you where I went wrong, and then we can redesign it at a later stage. I think, as far as I can tell, it's all okay, and it should be working. What I do need to do is add a switch so I can toggle between the USB power or battery power when powering up this regulator or all the other regulators that we'll be adding on in the future. But that's looking very good. So thank you for watching today, and I will see you next time. On my previous video, Genie1236 made a comment that he wasn't too sure how the FS8205 is going to function, as the battery no longer has the ground connecting to the second source pin on the final diagram that I showed at the end. So I think may have missed some connections here, so I will just change the connections. So I may have misconnected some of the pins when I changed the layout of this symbol and this symbol at the end of the video. So I will just correct all of that if it's required, and then we'll just go from there. Another component that I need to add to this circuit is the 10 microfarad capacitor, which I will put on the output. You can see the battery will connect to this point over here and this point over here. When I connect 5 volts to this junction, the IC will start charging the battery through here, and then this will detect the voltages and the currents using the MOSFET, as I explained in my previous video. I believe I've corrected video Genie1236 was talking about, but if you have any feedback for me on this, please let me know. So I also had another comment from one of my viewers, basically with a recommendation on the buck boost converter, and basically the comment was that I should change the ground such that it's closer to the part itself, so obviously it creates a better ground plane, and the loops are smaller. So to do that, basically I need to change this layer. Obviously that's on inner layer 2, whereas the pots are on the top layer. So what I want to do is change this to here, and that should be okay.